Hey, good morning again. It's Thursday morning, the 12th of September, and this is kind of a supplemental video, a few minutes to the one I did earlier this morning and already have posted on YouTube, Chapter 3 of Healey. In that video I had said something I was going to do, and I realized later when I was doing the in-class discussion this morning in stats that I had forgotten to finish that piece out. So that's what this is about. One of the things that we were saying in the video this morning is we were talking about the median and the mean, and we had made the point that the median is the geographic center of the distribution. It's not influenced at all by the size of the values, how big the values are in quantity on either side of the median. So if for example we had this one here, 1, 2, 7, 9, 10, 11, and 15, 1, 2, 3, 4, 5, 6, 7, we know that this is the median. We could do the formula because we already have. I'm just saying this is the median. That's a geographic center of that distribution. If we were to change, if the total number in the n were to stay the same, and we were to say change this to 35, then the median remains exactly in the geographic center. It's uninfluenced by the change of the 15 to 35. So that's an important thing to keep in mind. On the other hand, the mean is very influenced by that. If we have a mean here of 15, and if I might, I don't know where my calculator is right now, but if we were to add 20 to this and make this 35, then that would change the mean. The mean would increase in value because we've increased this, and that would mean that while the median would stay here, the mean would be pulled to the right because the values to the right are larger. If we were to add, if we were to have this at 15, leave it at 15, and change this maybe to a 0, where the values here are lower, that would pull the mean this way. And you can demonstrate that to yourself if you were to add these up, and using this formula here, x bar equals the sum of xi over n, where this is the n, the total number of values, and you sum up the values, 15 plus 11 plus 10 plus 9 plus 7 plus 2 plus 0. If you were to add those up, that's what would be in the numerator, and you divide that by the number of values, and that would give you your mean. So if we have a value of 15 here, that would be one mean. If we added this 25 or 35 or 100, the mean would go up. But the median, because the numbers of values in the distribution are the same, would stay in the geographic center. It's a very important, useful distinction between the median and the mean. The median is the geographic center, uninfluenced by the values around it. The mean is not a geographic center, it's an average, and it's influenced by the means around it. So, or the values around it. It can be pulled to the left for lower values or pulled to the right, depending on what we change of the values in the distribution. That's a very important thing to keep in mind. And then we got a visualization that we use, that we'll use a lot more when we get to Chapter 5. And that is a distribution. And I'm going to draw this out. This is called a normal distribution. It's bell-shaped. Here's the low value, here's the high value. Here's the mean. And in those cases where the mean equals the median, then the median would be here and things are pretty normal. Again, when we're talking about plus and minus, any x's that are to the right of the mean going up to high are larger than the mean. So if we subtract the mean from any of these x's, we're going to get a plus value. All the x's to the left of the mean are smaller than the mean. So if we subtract the mean from any of those values, we can get a minus sign. So this is called the negative or minus side of the distribution, and this is called the plus or the positive side of the distribution, because what happens to values when on either side when you subtract the mean. Now, if the mean and the median are roughly the same, this is takes on kind of a normal, I don't draw it so well, but kind of a normal curve. It's symmetrical. Looks like a bell, shall we say. But if we have a case where the mean is larger than the median, then we'd have a curve that would look like this. We would have a curve that would be pulled to the right. Say, here's the median, and here's the mean over here. The values, this is the plus side, this is the minus still. The larger values to the right have stretched out the tail of the bell, and it's called a positive skew. And you'll see a section in Healey talking about that. On the other hand, if we have a situation where the mean is smaller than the median, in other words, it's pulled to the left, then we'd have a curve that would look like this. Let me draw that out a little more. Yeah. And here's the median, and here's the mean. So again, this is plus, this is minus. So it's pulled to the negative side. So this would be called then a negative skew. These are important demonstrations of the relationships within a distribution, but they're also important concepts. They're going to be very important to us. Particularly, we'll see it when we get to Chapter 5 in a couple of weeks. But I wanted this supplemental kind of video from this morning to point this out, to remind you about the relationship between the median and the mean. If they are similar, then you have roughly a normal distribution. But if one is larger than the other, then you get these skewnesses going on, and it's an important concept. So that's the supplement to the earlier video this morning, and I'm going to post this on YouTube as well. So, hey, it's Thursday, right? Have a good weekend out there. Be safe.